Hey there, welcome back to School of Tomorrow. So I wanted to go back to the Wayne Roberts site here where he defines the term Eutrigon as a triangle with a 160 degree angle. Now we get into the question right away, doesn't an equilateral triangle have at least one 60 degree angle? Like there it does have the 160 degree angle. That's your only choices, by the way. You either have one 60-degree angle or three 60-degree angles in a triangle. And do we want to exclude the equilateral triangle from the category of Eutrigon? Well, no. Obviously, it's a special case of Eutrigon, so we need to make sure that's important. Now, this guy, Wayne Roberts, he's very saying so-called square numbers in a very Bucky-like way, right? Applied to so-called square numbers. When we see something to the second power, out of reflex, we always say squared, almost. That shows we're educated, well-schooled. If it's third power, we always say cubed, right? And here, without reference to Bucky, because he's doing his own thinking, Wayne Roberts is like, you know what? What about a triangular unit of area? Now, I haven't found yet if he goes to a tetrahedron for volume, but that's certainly what we do in synergetics. So I haven't been looking at the Eutrigon Theorem, as it's called, right? So once you start realizing this guy coined the term Eutrigon, you can just go into Google, and all of a sudden you've got all these websites popping up, including some animations and so on, that tell you about the Eutrigon Theorem, which is a distinct entry in this book by Wayne Roberts. Like, he does prove this, and he coins the term. So what the Eutrigon Theorem is saying is that you take one of the 60-degree angles. If there's three of them, take any one of them, but otherwise take the one, and call the two rays coming out from that your A and your B. Right? Now, what's been interesting to me is that A times B is going to be the area of that black triangle in terms of ETUs, equilateral triangular units. That's what I've been focused on. I only just found out about this website. And now I realize, though, what the guy's famous for is this general result that if you take these two rays coming from the 60-degree angle and add them up, you get this area, total area. But now if you subtract the red triangle, right, that you're going to get the red triangle minus subtracted from the green and the blue is going to be the area of the black triangle inside. Okay, so that's an interesting proof, interesting results, and there are many proofs, a lot of them animated, and it should be distinguished from the Pythagorean, but actually this would also, they both be true at the same time. If we make a equilateral triangle on top of all three edges of a right triangle, which we're free to do, right? We're allowed to put this little dot anywhere we want, and it just matters that the shapes are similar. They don't have to be squares, they don't have to be triangles. This generalization of the Pythagorean theorem is not often taught, unfortunately, right? Because this one's important, so I'm just trying to just leave it there. So let's look, where's the Eutrigon Theorem here? It's differently labeled now. A and B, by convention, are the two rays coming out from your 90 degrees. So your 60-degree angle is over here on the right. So the real A and B from the point of view of the Eutrigon would be, B would still be B, so let's say A would be the edge of the red triangle. And what we'd be saying then is that red triangle plus green triangle minus the blue triangle equals the black triangle in terms of area. That's the Eutrigon. Now, in terms of Pythagoras, it's different. It's special case. If it is a right triangle, blue plus green equals red, not red plus green minus blue equals black. Two different theorems, but they come together. They both apply in the case of a right triangle. All right, so that's all very cool. Now, in the Bucky meth, we add yet another radius coming out from the Eutrigon. We've got this third number line, you could call it, and we multiply A times B times C the same way to get not the area but the volume. And this time the unit of volume is, we could call it an ETU because T for tetrahedron, that would be confusing because Wayne Roberts has ETUs being flat, but I'm just saying it's an analogous, totally analogous process. And that becomes our basis for the whole number volumes at that point, the concentric hierarchy. Now, it's not that all of our volumes are whole number. It's not that we deny, we being people who go with this particular philosophy, don't have to say, oh, well, there's no such thing as incommensurability. The icosahedron here has 18.51 ... volume compared to the unit over here with the same edge lengths, right? That's our unit tetrahedron. Octahedron is 4. The cube with face diagonals equal to the control length, i.e. the length of the edge of the tetrahedron equals the face diagonal. We know that's 3, and so on. This is what in School of Tomorrow we consider basic, right? This is like knowledge that we definitely can pass on with great confidence. The problem is this too dangerous for like so-called public schools that don't teach this American heritage at all, and yet it's so basic. And I think you'll see that shoring up the idea that Bucky was a crackpot, right, is going to be important to keep this stuff from. We don't want the floodgates to open. We don't want the whole number volumes to pour into, by we, I mean like those of us who are trying to control the flow of information so that this design science revolution memes and all these other memes that connect in the fuller syllabus, we got to keep those out of the mainstream, I think is what we, I would say we in quotes because I'm not playing that game, but what we need to do is shore up the Bucky crackpot myth, and how we do that is always interesting to watch. You know, poor Bucky the failure because humans are still screwed up, and if he'd been a success, we'd all be enjoying higher living standards, but we're not, so the guy must have been crazy, right? That's a very, very illogical way to argue, but you know, he's got patents. He's not a failure by any standard. The guy had all kinds of awards. How many honorary degrees? That's where they just give you a PhD. You don't have to like spend money for it. That's not something to just sneeze at, actually. And he had a lot of those, and awards and patents. And then people go write in the Wall Street Journal that the poor guy was a failure. And anyway, it's crazy. It's just insane. So glad I discovered the Wayne Roberts website. That's going to really help with School of Tomorrow stuff. Talk to you later. Bye-bye.